and welcome into part 2 of polynomial distribution, my party people. In today's class, it's going to be just like the previous lesson, where we're going to go over those rules for distributing polynomials, multiplying, and combining like terms when it comes to adding and subtracting. We're going to go through those two things, but it's going to be more so like a quick, high-level overview, and then we're going to get straight into that timed practice with those test-level questions that you can expect yourself to see. So with that said, everybody, what we're going to do first is we're going to remind ourselves of these notes. So I'm going to first begin by turning it over to this page here. I'm going to give you a moment to take any notes down if you don't have them. And as always, I recommend going back to the recording of lesson 1 if you feel like we need that refresher. All right, so continuing here to the second set of notes that we did go over yesterday. Again, I will give you a nice moment to go ahead and write this down. But here are the notes again. Remember that when we are combining like terms, remember that you can only combine terms if they contain the same variables and the same exponents on those variables. That's when you know you can combine like terms. And so what you'll do when you combine like terms is you're going to go ahead and add or subtract those coefficients depending on the signage that you're looking at. So you'll either add or subtract, right there, and then you'll leave the variable and exponent the same. So let me just go ahead and write out a quick example before I allow you to write this down. So here's what we do. If we have, let's go ahead and say 4x squared plus 3x squared. Well, these are indeed like terms, everybody, because we have the same variable, x, and we have the same exponent on those variables, a 2 on each of those x's. So that's going to allow us to add these together. And so what we'll do is we are going to add the coefficients, the 4 and the 3. We'll add those together, giving us 7x squared. Again, leaving that variable exponent combination the same. My party people, does that make sense before we continue? All right, so moving forward here to the distributive property. So this is the bread and butter of what we're doing here and in yesterday's lesson. So here's the main idea. When it comes to the distributive property, the rule is make sure that everything from one parentheses multiplies with everything from the other. So for example, everybody, let's say we have 2x multiplied by x plus 5. Well, our goal is going to be to make sure that the 2x multiplies with the x, and also that the 2x multiplies with the 5. So every term that you see inside the parentheses needs to be multiplied by what's on the outside. And on top of that, this isn't the only way that you're going to see it. I think we can all agree on that, right? This isn't the only way that you'll see it. We explored yesterday instances where, well, what if we have, let's say, 2 parentheses, like x plus 2 times x minus 9 or something like that. Well, the same rule applies, everybody. The same rule applies. We are still going to make sure that everything from one parentheses multiplies with everything from the other. Same rule, same process. We are just going to say, hey, here's our x. I'm going to make sure that it multiplies with this x, and also make sure it multiplies with that minus 9. And then we're not done, because this is just one of the things in one parentheses. We need to make sure that everything from the parentheses multiplies with everything from the other. So what that means is, all right over here with this 2, we'll make sure it multiplies with the x, and also make sure it multiplies with that minus 9. Everybody, before we continue, does that make sense to you intuitively, or at least as a refresher before we get into these examples? All right, so let's go ahead and get into our first example problem. And as you can tell, we are starting small, but we are going to increase the difficulty as we go along all the way through those different topics. So first things first, my party people, when we check out the nature of this problem here, we have 3x and 4x. Can y'all remind me real quick, what is the operation signaled by that dot between the 3x and 4x? Correct, that is multiplication. So as a reminder, when we are multiplying terms, remember, here's what we do. We are going to take the coefficients, the numbers in the front, we're going to multiply those things together. Everybody, you know me, I'm bad at math. What is 3 times 4? Correct, that is going to be 12. Then from there, we have to understand full and well what x multiplied by x is. And everybody, what is x multiplied by x? Now Marevni is saying with the x squared, Giovanni x squared, perfect. It is correct. Now let me help you understand why. Everybody, what operation do we use for the exponents when we are multiplying those variables? What operation do we use with the exponents themselves? Addition, that's correct. And if we don't explicitly write an exponent, what exponent is always there? A power of 1, that's right. So we're going to have a power of 1 right here and a power of 1 over there. So basically all you're saying is, hey, I'm multiplying one x and another x together. So that's x times x. But another way of saying that is x to the power of 2. In the same way that 5 times 5, that's 25, sure, but that's also written as 5 to the power of 2. So just remember those examples to help you, guide yourself along. But this is going to be 12x squared. There's our first example. Are we good enough here to move forward to example number 2? Right on. So let's go ahead and do so. Let's take a look at the next example using a similar operation, multiplication. However, everybody, are the rules that we're following going to change because we have multiple variables, negatives? Is anything going to change? Right, nothing's going to change. Nothing's supposed to change. As long as we are committed to following the rules, we're good to go. So here's how I would handle this, everybody. Notice that we have signs, we have coefficients, so those numbers in front, and then we also have variables, multiple variables. Let me show you how to handle this. I like to go through a step-by-step approach. With step 1, I like to go ahead and worry about the signs. Everybody help me out. What's a negative number multiplied by a positive? Yeah, that's going to be a negative. So I'll go ahead and begin by writing a negative. Then, step 2, I'm going to focus my attention on those coefficients, the numbers in front. Again, this really helps us take control, especially if we're feeling a little bit nervous. So I have the 5 in front of those variables, and the 2 in front of these variables. Everybody, 5 times 2, that is going to be 10. So notice, systematically, going with the sign first, then the coefficients. Now I'll go ahead and move to handling my variables. And remember, when we're multiplying, we can only multiply variables of the same letter. So here what we have is a squared right over here, and then we have just a regular old a there. This is not to be confused with a to the power of 3. That is not what's happening. This is just a. It is b that is taken to the power of 3. That is b cubed. The a is not cubed. The a is by itself. Everybody, before I continue, does that make sense? Again, this is 2 times a times b cubed. The difference is that if we had ab all cubed, then the a would be cubed. But we don't see a parentheses, so we can only assume that it's just the b. So nevertheless, let's move forward. Everybody, we're going to add those exponents. So we have a to the power of 2 times a to the power of 1, because remember, that's what the exponent is, even if it doesn't show. So we add those exponents, and that'll be a to the power of 3. That's correct. And now one last thing to do. We're going to move forward here and finalize by taking care of the b term. So we have b multiplied by b cubed. And yeah, that's going to be b to the power of 4, because we have b to the power of 1 here, the 3 right over there. So we add those exponents and we get b to the power of 4. So with that said, I want to make sure that y'all understand when we're working with multiple variables being multiplied, we're good. We don't have to mix those variables together. We're not supposed to. It's only the same variables that can be multiplied together. The rest can just be attached at the end. So one more time, I see some folks asking, hey, why is it a to the power of 3? Why is it b to the power of 4? Well, let's go back to our rules here. Whenever we are multiplying terms, remember, we're going to multiply those coefficients, those numbers in the front. And then when it comes to the exponents of the variables with the same letter, we're going to add those exponents. And just to go over why that's the case again, let me just remind you, for this a squared right here, a squared is the same thing as a times itself twice. That's what the squared actually means. A squared means a times itself. When we think about this a sitting there, that's just a. That is just a. So when we multiply these together, we are now going to have 3 of those a's. And since we have 3 of those a's, a shorter way of writing that, so we don't waste time all the time, that's going to be a to the power of 3. So that's how we get the a to the power of 3. And similarly, that's how we get the b to the power of 4, because you have 1 of them here, 3 of them here. That makes 4 of them being multiplied. So Mulkey and Z, I'm glad that makes a little more sense there for us. Now, with that said, my party people, are we ready to proceed to the next example? All right, sounds good. So I want to give you a chance to try this one out. So let's move forward here. Let's try this one out. So first things first, like I said, if you don't know where to start, the best way, in my opinion, is to first, take a moment, take a breath, understand what's being asked of you to do. Everybody, one more time, because that dot is right there between these two terms. What operation are we dealing with? Yeah, that dot in between them means we're dealing with multiplication. So now that we know we're dealing with multiplication, let's go ahead here and multiply one thing at a time. Let's first worry about the signs. Then we can worry about the letters, the numbers, the coefficients here in the front. Then each individual letter, like multiplying the m's, multiplying the n's as in Nancy, and then bringing that p there at the end. Again, one step at a time. So here's how easy it can be when you break it down like that. Everybody help me out. If we have a positive number times a negative number, the result will be what? Correct, the result's going to be negative. So we'll say equals negative whatever we're going to write. Then up next, let's worry about that coefficient. We have a 3 here in the front and a 4 over here in the front. 3 times 4, my party people, that's going to be 12. Exactly. Very similar example to the previous one. It's just slightly more visually complex, but we're still following the same rules. Let's move it forward here to handling each individual letter, each variable. We have m to the power of 3 right here and m to the power of 2 over here. So everybody, how many m's are being multiplied together? If there's 3 over there, 2 over there, total we have 5 of them being multiplied together. And instead of writing m times m times m times m times m 5 times, no, we're going to shorthand it and just say m to the power of 5. Because again, that's what an exponent is. How many times numbers are being multiplied together. From there, let's keep it going with the n. So up next with the n, let's grab some blue highlighting and grab that n to the power of 2 over here, n to the power of 5 over here. Pop quiz, what do we do with the exponents when multiplying variables of the same letter? Correct, we add. So we have n squared and n to the power of 5. That means we have 7 of those n's being multiplied together. And then lastly, my friends, even though we don't have a p over here and we do have one here, what do we do with the p? Yeah, we just bring it down. We just bring it down. In the same way as, hey, if I'm multiplying 5 times x, well, you can't really mix the two, so we just write 5x. So it's the same deal. There's nothing that the p can mix in with, so we're just going to go ahead and attach the p at the end. That's it. Super straightforward, and we are done. So our final answer, everybody, so I can write it down in one color, is negative 12 m to the power of 5, n to the power of 7, p. Boom. And there we go. Again, yes, if we are multiplying the same letters, we are going to add those exponents. That is the power law of exponents. That's how that works. So with that, I'll go ahead and zoom on out. I'm sure that most of us have had a chance to write that down. And now let's go ahead here and take it to the next subtopic of combining like terms. Starting over here. So we have 7x plus 3x. My party people, quick question. Do we have the same variables? Yes, we do. Do we also have the same exponents, though? We have the same letters. We have x on both. But do we have the same exponents on those variables? Oh, we do. Nice. I agree. I agree. Because remember, everybody, if it's not showing, it's always a 1. So essentially what we're saying, and this is a similar thing that I said yesterday, is, hey, if we have 7 of these x's, let me go ahead and just write a box there. If we have 7 of these things, and we have 3 of those same things, well, we now have 10 of those same things, which in this case is just going to be x. So 7 of these x's plus 3 of those x's, that means we have 10 of these x's available. I like to treat variables as objects. It's a lot easier to think about it in that way when you are adding and subtracting like terms. So with that said, everybody, I know that was a quick one. That's a little warm up there. Are we ready to make it slightly more complicated? Sounds good. Let's keep turning it up. Here we go. Let's take a look at this next one here. When we look at this, I know it's very easy to potentially feel overwhelmed by this. I'm not gonna, sugarcoat it. It looks a little daunting, but let's go ahead and make sure that we are following our progression. Everybody, what do we need to combine like terms? What do we need to know about them? We need the same what and what. We need the same what and what. Yeah, we need the same exponents and the same terms, the same variables with those same exponents. So quick question, everybody. Let's go ahead and just start from the beginning and go to the end. Do we have, when we look at the 4a squared, do we have another a squared term? Yeah, we absolutely do, right here. Those are the only terms that we can combine. Yeah, sure, we have another a term over here, but it's not an a squared term, it's just an a term. So these are not like terms, these are not like terms, but these two are. My party people, does that make sense before we proceed? Right on. So let's turn our attention back over here to the frame and let's give this a shot. Some common mistakes are gonna look like this. You see a 4 here, you see a 6 there. Some folks might be inclined to say 10a squared, but that is wrong. That's wrong because we have a negative right there. That's a minus. So the way that we are going to treat this, let me move this off to the side. The way that we are going to treat this is going to be by saying 4a squared minus 6a squared. That's how we should be treating it. So the way that we're looking at it is 4 minus 6. When you flip it the other way around, 6 minus 4, that's a positive 2. So if we flip the order and do 4 minus 6 instead of 6 minus 4, what kind of a 2 are we gonna get? Yeah, that's a negative, exactly. We are going to get a negative 2a squared. As a reminder, we keep the same variable and exponents when we are combining terms. It's when we're multiplying that we modify those exponents. It's when we are adding and subtracting like terms that we keep the variables the same. So just keep that in mind and remember that. But after that, everybody, I think we're done because we've taken care of these two like terms over here. Everybody, is there another like term with 9a aside from these two? Is there any other like term? No, there isn't. So all you're going to do, your only responsibility, is to bring it all down. So the plus 9a, bring that down right there. That plus 2, nothing else to combine with that, so just a plus 2 right there. And so that's it. That is it, everybody. This is a part of the process that's going to take place when we are getting into, multiplying and distribution and doing all that stuff. But, this is a small piece, and I want to help you recognize how to combine like terms. Yeah, it can feel simple for sure once it all makes sense. Yes, you do still have to write it, though, with the addition, because remember, you're writing an expression. You're not writing negative 2a squared and a 9a over here and a 2 over here. No, this is all one expression, so you will be including those operators between those terms, for sure. So with that, let me zoom on out a little bit. There we go. Let's go ahead and give this next one a shot, and I'm going to turn the attention over to y'all to give this a shot here in about a minute. So if you are watching this as a recording, feel free to get your timer out. If you're here live, you know what to expect. And we'll go over the problem shortly right here. All right, and let's go ahead and get into the next example here. Even more complicated than it was before, but again, Remember that we are here to follow the rules that we know are true. So here we go. First things first, what can we combine? Let me start off with the first term. Everybody, we notice that we have a b to the power of 3, so b cubed. What is the other term that is a like term to 5b cubed? Correct, that's going to be 8b cubed. These are the same variables and the same exponents. We can combine those terms, and keep in mind that that is a plus, that is addition with the 8b cubed. Now, before I continue, are there any other like terms that we can combine? Oh yeah, there absolutely are. What are those two terms? Yeah, the b squared terms, Lamar, that is correct. We have a minus 2b squared right over here. And then we have a plus 7b squared. Nonetheless, though, we have the b squared as that common term. So boom, right there. There we go. And then once we take care of the b cubed and b squared terms, is there anything that is combinable with the minus b over here? Right, there's nothing left. We're all good, nothing left to do. So let's move forward now and combine those terms and keep it moving, keep it pushing. So here we go, 5b cubed plus 8b cubed, everybody. What is 5 plus 8? That was quick, yep, that is 13. So that's going to be 13b to the power of 3. Then up next, we have minus 2 and plus 7. Remember that negative 2 plus 7 is the same as 7 minus 2. Everybody, what is 7 minus 2? Yeah, that's going to be 5. So that means negative 2 plus 7, that is 5 as well. So what we have over here in green is plus 5b squared. And then this minus b right there, we just drop it down and we just have minus b. And that's it. We're good. We have successfully combined like terms again. So with that, I want to remind us that, yeah, when we are combining like terms, remember that we treat the variable in exponent combination as its own, term. So we have 5 of these things and 8 of those same things. So now we have 13 of those b cubed, of those b cubed terms. Again, this is when we are adding and subtracting. When we're multiplying, we would absolutely add those exponents because it's b times b times b times b times b times b, and that would be 6 b's. So that would be b to the power of 6. But it is not the same case here because we are adding, not multiplying these two terms. And then over here, when we take a look at the negative 2 plus 7, right over here, negative 2 plus 7, all I did was use this little thing called the commutative property of addition, where if I have 1 plus 2, it's the same as 2 plus 1. So I looked at negative 2 plus 7, and I can bring that 7 up front, and that'll be 7 plus a negative 2, which is the same as minus 2. Negative 2 plus 7 is 7 minus 2. That equals 5. So wanted to go over that one more time for us before we move over to the distribution. But my party people, are we good to take it up a notch to the distribution and then straight into that time practice? Let's go ahead and dive on in here. Right here, first up, we have 6y multiplied by 2y minus 5. So true or false, when it comes to polynomial distribution, we are going to make sure that everything from one parentheses multiplies with everything from the other. Yeah, absolutely. Absolutely. So let's go ahead and take care of that right here. We're going to make sure that the 6y multiplies with the 2y. And we're also going to make sure that the 6y multiplies with that minus 5. So now that we understand that, let's perform each operation separately. And if we can combine like terms, we would. I am going to say that we cannot because 2y and negative 5 cannot be combined. So it's going to be whatever it is after you're done multiplying. So here we go. 6y multiplied by 2y. Help me out, everybody. Let me actually just write it down first. So 6y times 2y. And then we're going to have the minus because, again, this is a negative. A positive times a negative is going to be a negative. And then we're going to have 6y multiplied by 5. So let's go ahead and get into it here, everybody. Let's get into it. What is 6 times 2 going to be? Yeah, that's going to be 12. And then if we have a y multiplied by another y. Y times y is what? In the same way that x times x is x squared. Yeah. Y times y is going to be y squared. There we are. Right there. Booyah. There we go. Then up next, we're going to write the minus, just bringing everything down. And then we have 6 times 5. 6 times 5, everybody, is going to be 30. 30y. And we are done. There we go. We've just successfully distributed. Again, just making sure that everything from one side of the parentheses multiplies with everything from the other. Are we ready to potentially try one out on our own? Sounds good. Let's go ahead and try this next one on our own. For those of you watching the recording, just pause it, give it a shot, and then press play. So here we are, everybody. Let's go ahead and get into this next example where we're looking at a slightly more complicated one, but we know that the rules that we're going to follow are going to be the same. So let's take it, again, just like we have been, one step at a time. Here we go. So first off, we have a negative 3x outside of the parentheses, and then we have 4x squared plus 2x minus 7 inside. Everybody, can you tell me how many times we're going to be distributing the negative 3x? How many times are we going to distribute it? Correct. That's going to be 3 total times. Let me go ahead and show how that's going to happen. We have the negative 3x multiplied with 4x squared. We have the negative 3x multiplied with the positive 2x. And then we have the negative 3x multiplied with the negative 7. That's how distribution works. Again, make sure that everything from one side of the parentheses multiplies with everything from the other. So here we go. Starting off, negative 3x multiplied with the 4x squared. Then we're going to have the negative 3x multiplied with the positive 2x. And lastly, we're going to have the negative 3x multiplied with the negative 7. So we have the 3 of these products, the 3 of these things multiplied together. Now, don't overcomplicate things. Simply work to simplify one at a time. One at a time, everybody. We can only do one thing at a time. Don't try to complicate it. So let's go ahead and simplify here. Quick. A negative times a positive. What's that going to give us? Yeah, that's going to be a negative. So let me just write that down. We'll have a negative. Then 3 times 4. That's going to give us what? Perfect. That's going to be 12. And then lastly, we have x multiplied by x squared. So how many x's are being multiplied together there? That's 3 of them. So that'll be 3 on the exponent. Again, because we are multiplying these terms, we are going to add the exponents of the same variables. Booyah, right there. 1 of these plus 2 of these, that's 3 of them being multiplied. Moving forward here to the second combination. Everybody, a negative times a positive, that's going to be negative again. And then we have 3 times 2, which is going to give us 6. And then x times x, everyone, is going to come out to be what? Yeah, that's going to be squared. So 6x squared. All right, now let's take it over to the last term here. Everybody help me out. We have a negative on the 3x multiplied with a negative on the 7. Negative times negative is a positive, correct. So we'll have a plus, because again, a negative times a negative equals positive, just as a reminder. Next up, we'll have the 3 multiplied by the 7, giving us 21. And we have this x right there, but no x in here. So what are we going to do with that x? Yep, just going to keep it. Just going to add it on right there to the end, just like normal. Yep, exactly. And so the final answer that we'll have here is negative 12x cubed minus 6x squared plus 21x. And there we are, my party people. All good. So there is yet another example that, again, it can look complicated. It can look complicated, but I think we have proven time and time again that it is one step at a time. One step at a time. Then you clean it all up one step at a time. Nice and easy. And then we get our final answer. So I'm really hoping that we're feeling good about that, everybody. I really do hope that we're feeling good. Now, are we ready for one more example? That is going to, again, be the epitome of what you will see when it comes to polynomial distribution. And then we're going to keep it moving forward. Good. Let's go ahead and get after it. All right, so let's take care of ourselves here. Let's get this next example going. So remember, everybody, we are going to be applying the same rules that we've done. Can anybody tell me, even though it's not explicitly written, what operation is happening between these two parentheses? What operation do we see? Correct, that's going to be multiplication. Multiplication up and down. Now, when we are multiplying sets of terms, so this is a 2 terms by 2 terms here. When we are multiplying sets of terms, what is that D word that we have been discussing that we will apply here? What is that D word that we have been discussing? Yeah, distribution, exactly. So to take care of distribution, everybody, watch and learn. Look at how straightforward this can be. I'm going to make sure that everything from one parentheses multiplies with everything from the other. That's how you're going to get it done. Notice that we have 2 by 2. 2 times 2 is 4. So you should be noticing 4 connections. 1, 2, 3, 4. 4 connections. So if you didn't know that was a little trick to make sure you know how many connections you're doing, yeah, it's going to be the number times the number. 2 by 2 is 4. But let's take it back one at a time. Here we go. So here with the x multiplied by x, everybody, I'll write that right there. Then up next, I'll go ahead and use a different color. I'll do x multiplied by the minus 5. So we'll have minus 5 times x. Up next, we'll do the 3 multiplied with the x, and that'll be a positive 3x. And then lastly, we have the 3 multiplied with the negative 5. And so that'll be minus 3 times 5, which will end up being 15 in a little bit. But now that we're done with that step, we can proceed to just clean things up. And then we might see that we have one more thing to do. So here, x times x, that's going to end up being x squared. Then we have 5x that is negative, 3x that is positive, and then we have 3 times 5, which is 15, and that'll be negative 15. So everybody, now that we've cleaned it up a little bit, there's one more thing that we need to do, and it's going to be 3 words. It starts with a C. Alex, appreciate you for being very quick on the trigger there. Yes, combine like terms. We are going to be combining like terms now. Let me write this down. We are going to combine like terms. All right. So we're going to be doing that right here with these 2 terms that we see. The negative 5x and the positive 3x. Those are the terms that we can combine because they have the same variables and the same exponents on those variables. So to get this done, remember that when we're combining, we're adding and subtracting. When we're combining, we are simply going to keep the same variable. We're going to keep that same x, but we are going to combine those coefficients. Everybody, a negative 5 plus 3 is going to look like this. Negative 5 plus 3. Remember that negative 5 plus 3 is going to be the same thing as 3 minus 5. It's the same thing. You can just rearrange it, bringing the signs with you. So you can say negative 5 plus 3 or 3 minus 5. Either way works. So everybody, when we look at it this way, 3 minus 5 is not 2. It's negative 2 because, again, the 5 is the bigger number. So whenever you are subtracting, you take the difference and you keep the sign of the bigger number. So that's going to be a negative 2x. Everything else just gets brought down. Everything else gets brought down, so you're going to have x squared minus 2x minus 15. And there we go. So the biggest thing about this problem, like a lot of the ones that you're going to see today, is remembering to combine like terms at the end. My party people, who feels like they're strong at combining like terms? Who here feels like they're getting there in terms of just, it takes a little more practice, but you will be getting there. Good. Yeah, again, it takes time. It takes time. Give yourself that time, patience, and grace. You're good. One step at a time. So with that, I want to move it over here to our practice round. Let's go ahead and get things going here. So let me go ahead and push forward. All right, so this is our first multiple choice practice question of the day. Let's get it going here. We have 4x multiplied by this group of terms, this binomial here, multiplied by 2x plus 3y. So let's go ahead and handle this with grace like we always have been. Let me zoom on in a little bit. And here we go. So we'll have 4x multiplied by 2x. So I'll write that down as 4x times 2x. And then from there, we have 4x multiplied by the positive 3y. So right there, 4x multiplied by the positive 3y. So with that, here we go. We have 4 times 2. Remember, we are multiplying, so we are going to multiply those coefficients. 4 times 2, that's going to give us 8. And then from there, x times x is going to give us x squared. Again, x times x is the same as x's being multiplied together. That's what a square is. From there, we're taking a look at the 4x times 3y. We have 4 times 3, which is going to give us 12. And then from there, everybody, x times y, how is that going to be written? X multiplied by y is simply going to be written as, xy, and that's it. They are not the same variable, so we don't do anything with those exponents. We just have them written down side by side, and that is it. This makes the correct answer here, answer choice A. Booyah, my party people. Now let's go ahead and keep it moving here to the next practice problem. All right, looking at our next practice problem with distribution. Let's handle it with grace. Let's zoom on in, get the problem in frame, perfect. All right, here we go. So one thing at a time. Remember, everything on the outside, the negative 2a, is going to multiply with everything on the inside. So we're just going to take it one step at a time. So first things first, we'll have the negative 2a multiplied with the 5a. I'll write that down right over here. Negative 2a multiplied with 5a. Next up, I'll take blue here to multiply the negative 2a with the negative 4b. So I'll write minus 2a multiplied with negative 4b. I'll zoom out just a little more to give myself some more room. And then lastly, we have the negative 2a multiplied with the positive 3. So we have negative 2a times 3. So now that we're here, we're going to take it again, one step at a time, one group at a time. So we have negative times a positive, so that's going to end up being negative. Then we have 2 times 5, and that's going to be 10. And then we have a times a, everybody. A times a is going to be written as a to what power? A to the power of 2. So we have negative 10a squared. So through observation, you might be able to tell that B is not the correct answer so far, because this is a positive 10a squared. This is a negative. So you can start eliminating as you go along for sure. Next up, in blue, we have the negative 2a times the negative 4b. We'll take it one step at a time like we did. Negative times negative, everybody, is going to give us a what? Negative times negative is going to yield a positive. That's correct. Then up next, we have 2 times 4, which is going to be 8. A times b, that's going to be written as just AB. That's correct. Boom. There we go. We're good. Now, next, we're going to move forward here to the negative 2a multiplied by the 3. Negative times a positive, that's going to give us a negative. 2 times 3, that's going to give us 6. And then we just bring that a that we see right on down. And that's it. There's our final answer. Negative 10a squared plus 8ab minus 6a. So with that, the correct answer here, my party people, is answer choice C. And there we are. Perfect. There we go. Now, let's go ahead and take it to the next step here. Let's try the next one out with the same patience and grace. All right, next example. We have ourselves 3m on the outside of the parentheses with 2m plus n on the inside. So how we're going to handle this is the same way that we have using that distributive property. So the 3m will multiply with the 2m, and then the 3m will also multiply with the n. So 3m multiplied by n. So now that we've done that, sweet, we're good to go. We are set. So now let's take care of each individually. So 3m times 2m, 3 times 2 is 6. M times m, that's going to create m squared. Remember, 2 of the same thing multiplied together, that is the same as squaring that item. Now up next, we're going to take a look at the 3mn. Well, there's nothing to multiply here. The 3, the m, and the n are all different. Those cannot be multiplied together. So we're just going to write 3mn, and that's it. All done. This one was a fairly quicker one relative to what we've been doing so far. But there we are nonetheless, everybody. There's the answer to that next one. Now, I hope you know that after every easy one comes a harder one. So let's go ahead and turn our attention over to the next practice problem. So let's keep it going here to our next practice question. We are looking at a binomial times a binomial. So 2 by 2, x plus 4 multiplied by x minus 1. So remember, everybody, because we are multiplying polynomials, we are following the same rule. Make sure that everything from one parentheses multiplies with everything from the other. So let's go ahead and give it a shot. Here we go, starting off with x multiplied by x. That'll be x times x. Then up next, we'll do x multiplied by -1. So minus 1 times x. Then from there, we'll turn our attention over to the 4 because we finished multiplying this x by both of those terms. Now we'll turn our attention over to the 4 where it'll multiply with the x, so plus 4x. And then lastly, we have ourselves over here 4 times -1. So I'll just write it as plus 4 times -1. So here we go. One thing at a time, everybody. Here we go. Everybody, what is x multiplied by x going to give us? X times x yields x squared. That is correct. Then we have -1 times x, and that's going to be the same thing as just minus x. Because remember, everybody, if there's a 1 in front, we don't have to write it. We don't have to say minus 1 apple. We can just say minus an apple. Okay, so that's what we have there. And then we have the plus 4x still where it is. And then we have 4 times -1. Everybody, a positive times a negative gives us a negative, making this answer here negative or minus 4. So that's the first step. Now we have to finish this off by combining like terms. We have to combine like terms right there. So to get that done, we take a look at which terms have the same variables and the same exponents. So when we check this out, x squared does not have a like term. It does not. It is this x term here and this x term there. I'm going to highlight both of them together to help us really understand that because they have the same variables and the same exponents, a 1 on the top, which you can't see at the moment, these are the like terms. So to combine these, we can treat this as a -x plus 4x, which is the same thing as writing 4x minus x. Again, you can swap them out. 1 plus 2 is the same as 2 plus 1. Just make sure to bring the sign with you. So now that we have that, everybody, we're essentially saying we have 4 of these x's and we'll take away one of those x's. How many x's do we have left? Correct. That's going to be 3 of those x's. And so we'll write that down right over here as x squared plus 3x. That's a positive because a positive 4 minus 1 is a positive 3. And then minus 4. And there's our answer. Our answer is x squared plus 3x minus 4. Again, that is correct because we treat this as a minus 1x. Just like we had it before, we just chose not to write the 1 because, again, the 1 is inherently there if not written. So with that, the correct final answer here, my friends, is answer choice D. X squared plus 3x minus 4. So remember, everybody, practice, it makes you better. Proper practice gets you where you want to be. So let's continue to practice the right way, trying it with that same patience and grace. All right, let's go ahead and tackle the next step of a problem here. Here we go. So when we check this out, we see that we have 3y minus 2 multiplied with y plus 6. All right, so with that, let's go ahead and remember that it's the same thing. We're distributing, polynomial distribution. Make sure everything from one parentheses multiplies with everything from the other. So here we go. We'll have the 3y. We will make sure that it pairs up with the y, so 3y times y. Then we'll make sure that the 3y multiplies with the positive 6, so plus 3y times 6. Then we'll continue with the minus 2. Make sure to bring that sign with you. That's one of the most common mistakes that we see. We'll have minus 2 multiplied with the y. So we'll have minus 2 times y. And then lastly, we're going to have the negative 2 multiplied with the positive 6. So negative 2 multiplied with 6. So with that, cool, there we are. Now again, we'll take it one step at a time. Here we go. So we'll go with 3y times y. Y times y is going to be y squared. So this turns into 3y squared. Up next, we have 3y multiplied by 6, and that's going to give us 18y. Next, we have negative 2 multiplied by y, which is minus 2y. And then lastly, we have negative 2 multiplied by 6, and that's going to be negative 12. So we have one more step to take here, and that is going to be combining like terms. We will combine like terms. And remember that terms are alike only if they share the same variables and exponents. So we have the negative 2y with the positive 18y that we can combine. And so everybody, as a nice final step, we are basically taking a look here at 18, positive 18, minus 2. Again, of the same variable. 18 of these y's minus 2 of these y's gives us 16 y's left. So that's going to be 3y squared plus 16y minus 12. And so the correct answer is going to be answer choice A. My party people, how are we feeling so far? We're making good progress here. We're taking it step by step. Do you feel yourself understanding as we go through? Are you able to go back and explain why things are correct and where potential mistakes may have come from? Gotcha, everybody. Let's go. Again, one step at a time, one problem at a time. We got this. So let's continue going with the next one. We have got this. Here we go. All right, everybody. So let's try this next one out. This one's a little unique, only because we haven't done it yet in this specific session. But let's go ahead and understand what we are looking at. So we check this out and we see the whole parentheses x plus 5 all squared. So if you're sitting here thinking, okay, that looks a little funny. I'm not exactly sure what I'm supposed to do. Am I supposed to just square the x and square the 5? No, that is the exact wrong thing that you should do. The correct way of going about this is understanding what squaring is. Now, let me express that. So 3 squared, let's just take a regular number. 3 squared is the same thing as 3 times 3. If we had everybody x squared, well, x squared is the same thing as x times x. So what am I getting at with this? What I'm getting at is x plus 5 all squared. That is the same thing as saying x plus 5 times x plus 5. Again, because if you are squaring anything, it is the same as that number multiplied by itself. My party people, before I continue, for those of us that may have been slightly confused on this specific part, does that personally make sense to you? Good. Right on. So again, math is really about understanding the library of rules and definitions to your advantage. That's really what it is. It's a language that you have to learn how to speak. So let's handle this like we know how. X plus 5 times x plus 5. Here we go. The x will multiply with the x squared. Then the x will multiply with the 5x. 5 multiplies with the x, 5x. 5 multiplies with the 5, and that's 25. From here, we're going to move forward here to combining like terms, which are going to exist between these two 5x's. 5x plus 5x gives us 10x. And there we are, everybody. We are all good. There is our final answer, and the correct answer will be answer choice C. And there we go. So just to review this one more time, since it is the first time we saw this. So remember that because we just had this binomial, this x plus 5, all squared, remember that squaring something is just the same as multiplying the same thing by itself. 3 squared is 3 times 3. X squared is x times x. X plus 5 all squared is x plus 5 times x plus 5. And so then from here, we would go ahead and just distribute like we have been doing, and then combine like terms at the end. I saw a question in the chat box that said, hey coach, if this was a 3, so like let's say we had x plus 2 all to the power of 3, that would be the same thing as saying x plus 2 times x plus 2 times x plus 2. That's what it would be, absolutely, because the 3 signals that you're doing it 3 times. So great questions coming out of the chat box there from everybody. I love that. Now let's go ahead and prepare ourselves for this next one. We've got this, and let's get it done. And here we go with the next example. So in this example, we have x minus 7. All of it is being squared. So remember, everybody, anytime any value is squared, it is the same as that value multiplied by itself. So because the entire x minus 7 is wrapped in a parentheses being squared, that means that we have x minus 7 times x minus 7. Again, the same thing multiplied by itself. So now that we have that going on, we're going to move forward like we have been with the distributive property. Everything from this parentheses multiplies with everything from the other. Here we go. We have x multiplied by x squared, x multiplied by negative 7, negative 7x. Then we're going to look to the negative 7 here, and let me just go up top. So negative 7 multiplied by x is negative 7x. And then negative 7 times negative 7. Well, a negative times a negative is a positive, and 7 times 7 is 49, so that's going to be plus 49. And there we are, everybody. And just to be consistent with the colors, give me 2 seconds. I'll go ahead and swap that out with blue, but that'll be plus 49. And now that we're here, it's the same old song and dance. We have distributed, so we've expanded. Now we're going to combine like terms, which exist between each of these negative 7x's. Now be careful, these are not going to cancel out. They're not going to cancel out. If we have negative 7 of this something, and then we take away 7 more, this is how we want to think about it. We want to think about it as, hey, we're already backwards 7 steps. Now we're going to take another 7 steps in the backwards direction. Everybody, negative 7 minus another 7 gets us to what number? Yeah, it gets us to a negative 14, because if we take 7 steps back and then another 7 steps back, we are going backwards or negative 14 steps. So that's a quick little crash course when it comes to working with negatives. As always, we have those resources for you to work with to really refresh and build that confidence. So just remember that even if that negative part is confusing, you are still doing a great job when it comes to learning about distribution. But the correct answer here for this one, my friends, is going to be answer choice B. And there we go. Again, everybody, keep learning from those mistakes. Keep learning from those mistakes bit by bit. All right, so let's go ahead and take it forward here to, again, another practice problem, but it's getting slightly tougher. We're doing the same thing. We're distributing. We're making sure that everything from one parentheses multiplies with everything from the other. I got you. But obviously, we see that we have 2 different variables. Doesn't change a thing. In how we handle each individual mechanic, sure, but it does not change the overall process. So let's get this done. We have 2x that we're going to distribute to the x, and we're also going to distribute to the y. So let's start with purple, 2x multiplied by x. Then in green, we see that we have 2x multiplied by y. Then up next in red, I'm going to multiply the negative 3y with the x. So that'll be minus 3y times x. And then lastly, we'll take that minus 3y and multiply it with the y. So minus 3y multiplied by y. So notice, I just took it one step at a time. That's all I did. That's all I focused on. So when we move forward to the next step, it's just going to be cleaning up each individual piece. And then if we can combine like terms, we can combine like terms. So let's go ahead and take advantage of that, move forward here. 2x times x, well, x times x, that's going to give us x squared. So that part right here is 2x squared. Next up, we see that we have 2x times y, and we're going to write that exactly how we see it. That's going to be plus 2xy. There's nothing to combine here, so we're good. Up next, we have negative 3y times x. Everybody, can we confirm in the chat box? Can we confirm that 2 times 3 is the same as 3 times 2? Can we confirm that? That both of those are the same exact thing? Exactly. Yep, they are the absolute same thing. So what I'm about to do hopefully isn't going to be terribly confusing. I'm not going to write this as negative 3yx. I'm going to write this as negative 3xy. So I'm going to write it in this way because it's going to allow me to see the like terms that I can combine. xy, xy. Does everybody see that there in the chat box? Again, I wrote it in alphabetical order so I can better identify and better understand, again, my like terms. Sweet. Now let's take it forward to the last part here, negative 3y times y. So we have negative 3, and then we have y times y, which is y squared. So we'll write that out, negative 3y squared, and we are good. So the last step that we'll need to take, like we said, like we noticed, is going to be combining those like terms right there. So let's go ahead and combine them and move it forward. 2x squared, we'll continue writing that where it was. Then we have a 2 minus 3. Everybody, what is 2 minus 3? What's that going to give us? Yeah, that's going to be a negative 1 because 3 minus 2, that's 1. But 2 minus 3, that's going to be negative 1. That's going to be negative 1. And so with that said, everybody, nice and easy, we are going to have negative 1xy. And then we still write that minus 3y squared at the end. But my party people, one last quick question. Do we have to write that 1 in front of the xy? Do we have to write that 1? No, we don't. So we can rewrite this as a final answer of 2x squared minus xy minus 3y squared. And there we are. And that's how we can determine here that the correct final answer is answer choice D. And there we go, everybody. Booyah, all set there. So I'll ask again, where's our confidence level at as we head into the next one? And here we go. Let's get to this next practice problem here. We are checking this out, and we have another binomial times a binomial where we have 5a minus 2b multiplied by negative a plus 3b. So we'll take this, again, one step at a time. Here, we'll make sure that the 5a multiplies with the negative a. So 5a multiplied by negative a. Then we'll make sure that the 5a also multiplies with the positive 3b. So that'll be plus 5a multiplied by 3b. Then from here, we'll continue with the negative 2b multiplied with the negative a. So minus 2b multiplied by negative a. And then from there, clearly need to go ahead and give myself a little more room. So I'll move it over to the left. And then lastly, we see that we have ourselves negative 2b multiplied with positive 3b. So minus 2b multiplied by 3b. Once we are certain that we have the right combinations written, again, just making sure that everything from one parentheses multiplies with everything from the other, we're all good. Now it's just a matter of cleaning it up with the multiplication, combining like terms if necessary, and then finalizing our problem. So here we go. We have 5a multiplied by negative a, beginning with the signs, that's going to be a negative. Then we have 5 multiplied by a 1. It is there. The 1 is there, even though you don't see it. It is always going to be in front if no other coefficient is shown. So 5 times 1, that's going to be 5. Then lastly, we have a times a, and that's going to be a squared, because again, anything times itself is that value squared. That's number 1. Let's go to number 2. Number 2 here, we have a positive times a positive, so that's going to be plus. 5 times 3 is 15. And then we have a times b, and that's going to be written just plainly so as ab. Next up, third round, we are taking a look at a negative times a negative. Negative times a negative is going to yield a positive result. And then we have 2 multiplied by 1, so that'll just be 2. And then b times a. Everybody, we can just write that as a times b. Again, b times a is the same as a times b. The only reason I swap them out is to show them in alphabetical order, because that's just the better way to write things down. It's just more natural, and it's easier to spot those like terms. So with that, let's go ahead and finish things up with the last one here. We'll have a negative multiplied by a positive. A negative times a positive, that's going to be a negative. And then from there, we have 2 multiplied by 3, which is going to be 6. And then we have b times b, and that's going to end up being b squared. For the same reason that x times x is x squared, a times a is a squared, b times b is b squared. And there we go. Now it's just a matter of cleaning up any common terms that we can combine, and that's it. And those common terms are right here. Positive 15ab, positive 2ab. Everybody, 15 plus 2, that's going to give us what? Yeah, that's going to give us 17ab. So the final answer here is going to be negative 5a squared plus 17ab minus 6b squared. And there it is, my party people. There is our final answer. Boom. Correct answer here in frame is going to be answer choice C. And there we go. So my party people, this is the end, but I hope you see that through all of the practice problems that we've done from start to finish here, we have really shown the same technique, the same process. It just got more complicated as the terms became different, but it's still the same process. It is up to you to continue working on your comfortability with negatives, comfortability with multiplying and combining like terms, and those little things that make up polynomial distribution, everybody. That's what it's all about. Practice one day at a time, one problem at a time, one topic at a time, and you'll be fine.